Ever wondered if we are alone in this vast universe? It's a question that has captivated our collective imagination for centuries. From the ancient Greeks gazing up at the stars to modern scientists peering through telescopes, we've always been intrigued by what or who might be out there. This curiosity isn't limited to science. It's woven into the fabric of our culture too. Think about the countless science fiction books, movies, and TV shows that explore the idea of extraterrestrial life. From H.G. Wells' War of the Worlds to the iconic Star Trek series, the notion of life beyond Earth has shaped our stories and our dreams. But it's not just the stuff of fiction. Serious scientific studies have also grappled with this cosmic question. And one of the most intriguing theories is also one of the most puzzling. Today we delve into a paradox that challenges our understanding of the universe and our place in it: the Fermi paradox. So, what is this Fermi paradox? Well, it all begins with a man named Enrico Fermi. Fermi was a brilliant physicist, known for his work on the development of the first nuclear reactor, and for his contributions to the development of quantum theory. But aside from his scientific achievements, Fermi was also known for posing thought-provoking questions. And it was one such question that sparked the concept of the Fermi paradox. During a casual lunchtime discussion with his colleagues, Fermi famously asked, "Where is everybody?" Now, he wasn't referring to the lack of people in the canteen that day. Instead, Fermi was pondering the existence of extraterrestrial life. The vastness of the universe, filled with billions of galaxies, each hosting billions of stars, each potentially orbited by planets, suggests a high probability that intelligent life should exist somewhere out there. Yet, despite our best efforts, we found no evidence of extraterrestrial life. No signals, no spacecraft, no signs at all. This puzzling contradiction forms the basis of the Fermi paradox. But let's delve a bit deeper. The Milky Way alone is estimated to be around 13 billion years old. Even if we consider that Earth-like planets have only been possible for the last 5 billion years, that still leaves a huge amount of time for other civilizations to have developed, and potentially, to have made their presence known to us. Yet, we've heard nothing. The Fermi paradox is not about proving or disproving the existence of extraterrestrial life. It's about questioning and exploring the seeming contradiction between the high likelihood of their existence and our lack of contact or evidence. It's about igniting our curiosity and pushing us to further explore the mysteries of our universe. So we are left with the question, if there are so many possibilities for life, why haven't we found any? To understand the Fermi paradox, we must first grasp the Drake equation. This equation is our cosmic yardstick, our attempt to quantify the unquantifiable, the number of civilizations in our galaxy with whom we could potentially communicate. Let's break it down. The Drake equation is a formula that multiplies several variables together. It starts with the rate of star formation in our galaxy, then factors in the fraction of those stars that have planetary systems. Next, we consider the number of planets per solar system that could potentially support life. This is where things get interesting. With the discovery of exoplanets, we now know that planets orbiting in the habitable zone, the Goldilocks zone where conditions are just right for life as we know it, are not as rare as we once thought. The equation then takes into account the fraction of those planets where life actually develops, and of those, the fraction that evolve intelligent life. As we look at the history of life on Earth, we see that intelligence is not a guaranteed outcome of evolution. It's a wild card, a variable that could radically alter the results. The final two factors in the Drake equation consider the lifespan of an advanced civilization and the length of time it would be able to communicate. This could range from a few decades to millions of years, depending on a civilization's technological advancement and its ability to avoid self-destruction. So, we multiply all these factors together, and we get an estimate. A number of civilizations we could potentially communicate with. It's not a precise number, but it's a start. It gives us a sense of the vast possibilities that our universe could hold. Yet here's the paradox. Given the age of our galaxy and the potential for life suggested by the Drake equation, we should have heard something by now. Some signal, some sign that we're not alone. But so far, nothing. So, with all these potential civilizations, why is it so silent out there? Opening. The silence of the cosmos has led to many theories. If the universe is so vast and teeming with potential life, why haven't we heard a peep from our interstellar neighbors? Some of the most popular theories attempting to solve the Fermi paradox range from the chilling concept of a great filter to the idea that advanced civilizations might be invisible to us, or that perhaps we're just not listening properly. First, let's dive into the chilling notion of the Great Filter. This theory suggests that at some point in the evolution of a civilization, there is a hurdle or filter that is incredibly difficult to overcome. It could be anything from a global catastrophe like nuclear war or a pandemic, to a resource depletion or environmental collapse. If this filter is in our future, it could explain why we haven't heard from anyone else. They may have all met their end before reaching a level of technology that would allow for interstellar communication. Next, consider the possibility that advanced civilizations are simply invisible to us. This doesn't mean they have some sort of cosmic invisibility cloak, but rather that they may exist in ways that are beyond our comprehension or detection. Their technology might be so advanced that it's indistinguishable from nature, or they could be communicating in ways that we don't recognize as communication. Imagine trying to explain the internet to a medieval peasant. It's possible that we're the peasants in this scenario, oblivious to the cosmic internet buzzing around us. Another theory is that we're simply not listening properly. We've been broadcasting and listening for radio signals for a little over a century, which is a blink of an eye in cosmic terms. And we're limited by our own technology and understanding. We can only listen for types of signals that we ourselves can produce or recognize. It's like trying to catch a wave on a surfboard when you're sitting on a lily pad. We might just not be equipped to receive the messages that are being sent. Or perhaps, we're just too early. In the grand time scale of the universe, human civilization is a newborn. It's possible that we're among the first wave of civilizations, and others have yet to emerge. Each of these theories is intriguing and somewhat unsettling, but they all highlight one fact. We have so much more to learn. We're like children peeking out of our bedroom window at night trying to understand the vast and mysterious world that lies beyond our front yard. Closing. Each of these theories brings its own set of questions and implications. Why does the Fermi paradox matter to us? This is a question that many of us might have thought. The Fermi paradox is not just a conundrum for astronomers or science enthusiasts, it holds profound implications for all of humanity. The Fermi paradox prompts us to ask fundamental questions. Where are we in the universe? Are we alone? And if not, why haven't we heard from other civilizations? These questions push the boundaries of our knowledge and fuel scientific research. The paradox has been a driving force in the search for extraterrestrial intelligence, inspiring new techniques and technologies to scan the cosmos. In addition to spurring scientific progress, the Fermi paradox forces us to confront our future as a species. If there are countless civilizations out there, why is it so quiet? Some propose that civilizations might inevitably self-destruct. This is a sobering thought, challenging us to ensure our longevity as a species. We are forced to consider our actions and their potential consequences on a cosmic scale. But let's not forget, the Fermi paradox also opens up exciting possibilities. Perhaps we are early in the cosmic timeline, and we are among the first intelligent beings, or maybe civilizations are out there, but they are so advanced that we can't comprehend their signals. These ideas push us to broaden our understanding of what life and intelligence could be. The Fermi paradox is not just a scientific puzzle, it's a philosophical and existential challenge as well. It forces us to think about our place in the cosmos, our future, and the nature of life itself. It stirs our curiosity, our fear, our wonder, and our hope. As we continue to explore the cosmos, the Fermi paradox serves as a reminder of the great mysteries that still await us.